Hello guys, welcome once more to another video in our YouTube channel. So in today's video, we are going to be looking at Northwest Regional Mock 2025 Pure Maths Paper 2, specifically question 10. So this question caught my attention and some students had a lot of difficulties in answering this question, so I decided to make a video explanation to the question. So for those of you who are just joining us for the first time, make sure you like the video, share the video with your friends, and you also subscribe to the channel. The comment section is open for you if you encounter any problem while going through the solution. Alright, without wasting much of your time, let us get started. Alright, so how do I state the coordinates of the point A? The coordinates of a point, we need to give the x coordinate and the y coordinate. Now we clearly see that at the point A, the point A is basically on the y-axis, which means that the x coordinate is 0, okay, and also the y coordinate is 10. It is clearly indicated to us. Now if this 10 was not indicated to us, we can already come to the equation of the quadratic and replace x to be 0, because a point A is a point of intersection of the line and the quadratic, and it is perfectly on the y-axis. So if you replace x with 0 and x with 0, you're going to get a y coordinate of the point A to be 10 and the x coordinate to be 0, because it is on the y-axis. So clearly the coordinates of the point A is 0 and 10. 0 for the x coordinate and 10 for the y coordinate. Alright, show that b is equal to 5. So we have the information that the point capital B is a point of intersection of the line L and the quadratic. So which means that the point capital B belongs to the line L and the quadratic. Since we don't have the equation of the line, but we have the equation of the quadratic, we are going to use the equation of the quadratic. Now, what do we mean by saying that a certain point belongs to a certain curve or a certain line or whatsoever? We mean that the x and y coordinate of that point should satisfy the equation of that curve or the equation of that line. Okay, since the coordinates of b are small b and small b, it means that this x coordinate and y coordinate should satisfy the equation of the quadratic, since we don't have the equation of the line. Now what does this mean? This means that whenever we replace the x coordinate of the point b with small b, the result must give us the y coordinate, which is also b. So we write our statement that the point B belongs to the line if and only if when the x coordinate is B, the y coordinate is also B. So we just have to replace the x coordinate with B. So you're going to have B squared minus 6B plus 10, and we equate the y coordinate with B as well. Okay, so B will be equal to B squared minus 6B plus 10. We are going to subtract B on both sides. We get 0 is equal to B squared minus 7B plus 10. Now we can factorize the right hand side by just finding the factors of 10, that when we add we have negative 7, and when we multiply we get 10. Those factors are negative 2 and negative 5, which means that the right hand side can be factorized into B minus 2 times B minus 5. Equating everything to 0 and solving for B gives us that B is equal to 5 and B is equal to 2. But we have been told at the beginning that B is not equal to 2, which means that the only value of B we are going to take is B is equal to 5. So we have proven that B is equal to 5. And proving that B is equal to 5 means that the coordinate of the point B is 5 for the x coordinate and 5 for the y coordinate. Okay, let us go to question C, which is asking us to find the equation of the line L that is passing through the point A and B. So the equation of every line is given by y minus y0 equal to m into x minus x0, where x0 and y0 are the coordinates of a particular point that the line passes through, and m is a gradient of the line. So let us give the coordinates of A. We saw that the coordinates of A were 0, 10, and the coordinate of B is 5, 5, because the x coordinate is 5 and the y coordinate is 5, and according to the equation the x and y coordinate are supposed to be the same. Okay, so the equation of my line L will be either, we are going to consider either the point A or the point B as our reference point. So you are going to have y minus 10. I consider the point A. My y0 is 10 because it is a y coordinate of A. Y minus 10 equal to m into x minus 0. Somebody could still consider y minus 5 into equal to m into x minus 5. We are still going to have the same response at the end of the day. I just consider x the point A, since the x coordinate is 0, and I will not have a lot of work to do here. Okay, so now we need to find m. That is the only missing term in our equation, m, the gradient. And the gradient of this line is just the gradient of the 2 points A and B, because the 2 points lie on the line. So we need to do change in y over change in x. Okay, so change in y will be 5 minus 10, and change in x will be 5 minus 0. So doing that, we get 5 minus 10 on 5 minus 0 to be negative 5 divided by 5, which is equal to negative 1. So my gradient is negative 1. It's negative because my graph is downward sloping. Okay, as the values of x are increasing, the values of y are decreasing. Therefore, change in y has to be negative. Okay, so just replacing into my equation, I get y minus 10 equal to negative 1 times x, because x minus 0 is x, and negative 1 times x is negative x. So let it resemble y equal to mx plus c. We are going to have y equal to negative x plus 10. So this defines the equation of the line passing through the point A and B, and that line has been given to us as L. Now let's go to question D, which is asking us to show that the distance between the point A and B is equal to 5 with 2 units. Since we have the coordinates of the point A and B, we can just use the distance formula. So the distance between 2 points is the square root of the square of the difference of the x coordinate plus the difference of the y coordinate. So here the distance will be the square root of, we need to get the difference of the x coordinates and we square. So anyways, I started with the y coordinate. So 5 minus 10 all squared plus 5 minus 0 all squared. 5 minus 10 is negative 5, and negative 5 squared is 25. 5 minus 0 is 5, and 5 squared is 25. So this is 25 plus 25, and 25 plus 25 is just like taking 25 times 2. Okay, because we are adding 25 to itself 2 times. Anyways, you are going to have 50. Now we can separate it into root 25 times root 2. Since root 25 is 5 and root 2 is root 2, because 2 is not a square number, then we are going to have 2 is not a perfect square, we are going to have the distance to be 5 with 2 units, and we have proven what we are asked to prove. So let's move on to the last part of the equation. Okay, in the last part of the equation, we have been asked to calculate the area of the finite region R that is bounded by the line and the curve. So let me just try to demarcate the region that is bounded by the line and the curve. So this region in red is a region R. So we need to calculate the area of that region. Okay, so we are just going to use the integral, the area as an integral. Okay, so the area bounded by this region, okay, is basically the integral from the first value of x to the last value of x. We see that clearly from here. We see that the region is bounded by x starts from 0 because it is on the y-axis, and x ends at the b coordinate, which is 5. Okay, so the region, the interval of x in that region is from 0 to 5. Okay, now the region is bounded by the line and the curve. Since the line is above the curve, we are going to take the line minus the curve. Okay, so the area involved is the integral from x equal to 0 to x equal to 5 of the equation of the line minus the equation of the curve. So line minus curve. So the line is just negative x plus 10, and the curve is x squared plus minus 6x minus 10. But when this negative sign multiplies every term in the curve, we are going to have negative x squared plus 6x minus 10. Now 10 minus 10 is 0, negative x plus 6x is 5x. So at the end of the day, we are going to have negative x squared plus 5x as the line minus the curve. Integrating from 0 to 5, you integrate term wise, and then you replace your upper bound and your lower bound. So integrate minus x squared, we get minus x cubed on 3. Integrate 5x, you get 5x squared on 2. You now need to replace the upper bound with 5 and then the lower bound with 0. Alright, so tell me your answer in the comment section. So I think we have come to the end of this video. If you love the video, make sure you like the video, you subscribe to the channel, and you turn on your notifications so that whenever subsequent videos are uploaded, you'll be one of the first persons to be notified to come and watch. Until then, stay blessed.